When thin films are watched in monochromatic light, dark and bright regions are seen. This happens because of the path difference, which depends upon the values of mu, t and r. White light consists of a spectrum of colors. At a particular point on the film, a certain wavelength will satisfy the condition for brightness. This color will appear with maximum intensity. The neighboring colors will appear with lesser intensity. Some other colors that satisfy the condition for darkness will be missing. Hence, the point on the film appears colored. When the thickness of the film is large compared to the wavelength of light, almost all colors will constructively interfere for some orders, and consequently the resultant effect is the sum of all colors or white. Let us see what happens when a film whose thickness is very small is watched in monochromatic light. If the thickness of the film is infinitesimally small, the optical path difference between the reflected beams becomes equal to lambda by 2 due to reflection from a denser surface. This will lead to a combination of crust and trough leading to darkness, hence the film appears dark.